Correct. All right. Just finishing that first one. All right. So, ooh, question. Gotcha. All right. So I see. So I need to. All right. I will figure that out and then get that to you, and then yeah, we'll take care of it. All right. So first thing I want to note. Okay, I want to go back to, and now Shelby's not here. This is, but where we had that plus or minus 6e to the x here, minus 4, in a similar kind of scenario to here, where we had the square root both sides, and we had plus or minus, we had to eliminate the positive one because only the negative one would result in this particular solution. Okay? Likewise, yesterday, okay, when we had the absolute values and we wanted to fix the absolute values by making a plus or minus in front of the ce to the x there, okay, we need to still eliminate, in this case, the negative, okay? We eliminate the negative, not plus or minus, it's just plus. We eliminate the negative because only the positive version of this will result in this particular solution, 0, 2, to work, okay? If we allowed the negative one, if I plugged in 0, it'd be e to the 0, which is 1, times a negative 6 minus 4 to be negative 10, and that is not a particular solution we're given there. So we want to eliminate that minus just the plus thing. Okay? So, anyways, let's continue on. We are only going to finish 5, 6, and example 7 here with the, multiple parts. So we're only going to finish up through this section. So just these, I guess 1, 2, 3, 4, 5 problems, okay, that we're going to do here. All right. So why don't you guys go ahead, though, and try number 5 there. Okay, give that one a try since, I think it's not too crazy. Nothing weird's going on there, I would say. So give it a try, okay? So given dw dt equals w squared over 4 plus t squared, and w of 2 equals negative 1, find an equation for w in terms of t. Okay, we're going to find the particular solution here. So go ahead and give that a try. All right, and I will as well. Okie dokie. This one could be dark though. These are. Oh, same thing.
You're gonna give it. You're gonna give it to me.
Oh, okay. So they're safe.
Yeah.
That's good.
This is what
I was like,
having like a brain block. When there's a 1/2 down the bottom, is it just you put a 1 on top and 2 like bottom, or is it a 2 on top?
The problem is because you have this whole quantity in the denominator like this.
Right.
Well, I guess because it's 1/2, I guess, to evaluate this. So R tangent 1, I would say you want
Pi over 4.
pi over 4.
Yeah.
So pi 8 plus c, you can multiply that quantity over here then, so it's negative pi 8
Oh, I
plus
see.
c, and then you can solve, continue to solve from there. Okay.
Wait, if you get it right?
Well, you're not done yet, right?
Tell me about it. I'm pretty shocked.
Yeah, it's looking good.
I can leave the C down the bottom though, right? That's
You want to solve for c though.
right. Yeah. So does C carry over with it?
I would say multiply it over with it, yes. But you can still make it a plus c because the negative is going to absorb into the c.
All right.
Plus c goes to yes, so as soon as you do that, you or in this case,
Alright, so I got no. I got negative.
Pi 8 minus 1 is negative 7 pi 8.
I know. I got to come on.
How did you get from the YouTube group parlay? How did you get this parlay?
What, the arctan?
Wait, how did you get that? Oh,
everyone's favorite inverse rate.
I don't know why. For some reason I thought that was.
Oh, I got you, yeah. Yeah, I gotta do the, let u equal the denominator. I was like, wait, it doesn't work. And I was like, oh shit, it doesn't work. It's a trick.
Recognize our outfits.
Megan and I both got numbers.
That's not enough though.
We have actually
They do. Yeah. So we just wore
2 matches 1 week back to back.
I know one person who got it.
And they're both fat. It's not even that they're like muscle.
Lawyer
Fat.
and ended up going to Notre Dame. Both undergrad law school. He's still in there.
The guy took a bad
So I was
shot on
telling
me.
him about you guys. He's actually at the house. So I was telling him, I looked at my right arm. He was there.
That's his argument.
He got waitlisted, I think, and ended up going to Notre Dame.
Which then you
Megan and I
say
both got it.
multiplies
And
plus or
exactly
minus.
one person got it.
And then once you convert it, it's all in.
Is that your number one?
Negative.
Friday. And then I'll hang out. I wish I knew. Now I
Okay, so then when do you hear like from regular?
That would be in March. Like, they
Oh,
offered
you're
it.
sorry.
5
5
years,
years.
just kind of like, nice, no, we're like, I
Yeah.
guess I know it's very good.
However, yeah, so, you guys are both very different.
But like, I have 7 exceptions.
Alright, let's do back.
So you're going to college?
Yeah.
We're
My handwriting's already really sloppy.
Carolina.
Wow, I've never seen this.
Hey, what's your digits, girl, so I can start telling you? What's your digits, girl? What's your digits? 911.
Yep, that makes sense. Right, so they're listed on the police.
That was my girl's name from.
Okay, we'll go over this next one here.
Okay, I tried this 4 times. I tried 4 times. There's no way you're
I love to change. I mean, if you get the Villanova,
So separate your variables.
Okay, I tried over the minute for 4 times. I get like 20 every way.
Yeah, so if you want to leave the 4 plus t squared, you're going to move the dt. Divide w squared.
And so for 4,000.
Okay, multiply both sides by 1 over w squared.
What is it?
1 4 plus t squared. The dt, you want to multiply that over because your t's together. So it should be w to the negative 2. You want to multiply both sides by 1 over w squared. You gotta get w squared from here over to here. The dw squared.
It's not like it's.
I'll give you like 1 more minute here to wrestle with this one. If you finish with number 5, you can move on to number 6. Yeah, now I'm speaking your language, right?
Yes, you are.
Well, I guess if you wanted to, you could.
Yeah, the bad part is that we have another one today. Back to back.
That's a lot. Who are you guys playing? Are you guys wrestling tonight?
Walkersville.
Okay. They're normally like pretty solid, right?
Yeah, well, sometimes they don't have a complete team. So,
Yeah, that's
and all their guys are like big and fat.
oh,
Like, not to be mean, or like, they like take their offensive linemen from football
Right.
and put them into wrestling. And I'm like, wow.
Okay. So first of all, here's the separation that you would like, that you should use. Not would like to, but you should use. Okay. W squared, right, is in the numerator here, but we need to move over because dw is on this side. Okay. The dt here, right? Dw. That's right. Arthur. It's funny, you guys think Arthur, I think back to like a TV show called Darkwing Duck, but like no one would know that because that's like from the 90s and stuff like that. So
You're old, Mr. Wood.
I am. So anyway, dw, we move the w squared over, 1 over w squared dw, and then the dt, that, so you always want to move whatever, it's dw dt in this case, whatever's on the bottom of your derivative, that should always move to the right, and that should be where you collect those variables, okay? So your top, derivative, in this case dw, your w's are going to be on the left. Your dt on the bottom, you always want to multiply that over and bring all your t's, in this case, to that right-hand side, all right? If it's dy dx, the dy is going to stay on the left side, the dx will move over to the right side, and keep it that way, okay? It's just a good kind of organizational rule for you to follow. So again, the w squared comes over as 1 over w squared, and then this is 1 over 4 plus t squared, okay? Integral of 1 over w squared, that's, a power rule. The integral of 1 over 4 plus t squared, what are we going to use here? Yeah, arctangent, okay? Blast from the not-too-distant past. So there it is, okay? And so I chose to use the u substitution here. Not really necessary, though, because it's just a t, right? So you could have just integrated right from this point. Okay? Don't forget that arctan, that is one of the inverses that's got the 1 over a in front. So you should have a 1/2 arctangent u over 2, right? Your a is 2 here, not 4. Right? 4 is 2 squared. Your a is 2 then. Okay? So, again, solving this side, you get negative 1 over w plus c equals that. Okay, I chose at this point to solve for c, not solve for w first. I chose to solve for c here. Okay, as a result, then, I end up with c equals 1 minus pi over 8. Okay, Again, it's your choice here whether you choose to solve for W first and then find C, or solve for C first and then find W, right? It's up to you how you want to do it. But there's the C value that I got. So substitute that back into our general solution. So now we have this particular solution. We want to get it for W in terms of T, and so get the W by itself. I multiplied, so the W's in the denominator here, multiply that W over, so it's W times this quantity, and then divide that whole quantity back over here, so it's -1 over this quantity right there. That's supposed to be a pi. Yeah, sorry. Okay. This does require a little bit of like algebraic gymnastics here to like get things where you want them to be. Okay. I will say, right, so a couple things to point out here one more time. I integrated that left-hand side before I was able to integrate the right-hand side, so therefore I had to put the plus C there. Okay? As soon as you integrate, either left or the right side, you got to put a plus C in, even if you're only integrating one side. Bless you. Okay? I ended up just moving that plus C over, right? Kind of math magic. Mr. Wade, you got a plus C on the left side, and then you made a plus C on the right side. Can you do that? Aren't you supposed to subtract C from both sides? Since it's a constant, right, that C can just move over, okay? So this C, where the position is here, will just be the opposite of where this C in this position here would be, okay? So you're going to end up with the same, an equivalent value, I'll say.
It goes from arctan of 4 over 2 to arctan T over 2 to arctan 2 over 2.
Sorry, that's supposed to be a U.
I'm so confused.
That's supposed to be a U. Because I did a U substitution here. Not necessary, not necessary. If you want to, you can just skip from here down to here if you need to. Say again? I used a U substitution, so that's a U, not a 4.
And then why?
But then what is U? My U is T. So I just replaced the U with the T. There was no need to do a U substitution there. Okay, bless you. What's that? I have re-substituted in for the U, which I said was just T. So. And then, of course, we used the 2 in for the T. Bless you. I guess I should really say here to here. Not there. Okay, you don't really need to use a U substitution there. Okay? So this kind of question is a popular, bless you, free response question, okay? Something like this would be worth about like 5 points, maybe even like 6 points, depending on a given free response. So like 5 or 6 out of your 9 points kind of thing. So getting just this would get you, like 5 out of 9 or 6 out of 9, which would again be putting you on your way to a 5, right? Roughly. Bless you again. Okay. So. Questions? I have some tissues over there if you need to use those too. So, okay. Questions on any of that? We can move on. Okay. So number 6 then, I think some of you guys already tackled this one, but let's take a look at it here. Which of the following is a solution to the differential equation with the initial condition? Okay. So we want to solve this differential equation here. Okay. We want to solve this differential equation. So we will separate variables. All right. dy, we'll move the y over, make it 1 over y dy equals, and then move the dx over secant squared x dx. Integrate. What is the integral of 1 over y with respect to y? Natural log absolute value of y. And that's equal to, what's the integral of secant squared? Tangent of x. And I'm going to put the plus c right in here. So we're integrating at the same time. Now we can use our information here, or we can solve for y first, because you can see all these are solved for y. So solve for y or solve for c? All right, I heard c first, so here we go. So -1 goes in for y, pi over 4 goes in for x. Okay. What is the tangent of pi over 4? 1, right? We just said the arctangent of 1 was pi over 4, so the tangent of pi over 4 should be 1, right? Natural log of, well, the absolute value of -1 is 1. What's the natural log of 1? 0, so we get 0 there. And so we get c equals -1. And so we have then, back to our original there, the natural log of the absolute value of y equals tangent of x minus 1. Okay. Of course, we want to get y by itself here because that's what we have. So how can we get y by itself? How can we solve for y here? E to the left-hand side, e to the right-hand side. Okay, those cancel. What's left over here? Yeah, absolute value of y. Okay, equals e to the tangent of x minus 1. Okay, so if you look here, right, e to the tangent x minus 1 is not an answer. Positive e to the tangent x minus 1, not an answer. Right, they're all negatives. But remember here, what can we do to kind of like, what can we do mathematically? Instead of an absolute value, we could write y equals what? Plus or minus the e tangent x minus 1. And of course, again, we don't see plus or minuses here, so we have to kind of convince ourselves that that plus can be eliminated. All right? And what piece of information here can help us to kind of see that we need to eliminate the plus? What information given to us here is going to help us realize that we need to eliminate the plus, and it's going to be the negative e to the tangent x minus 1.
All the answers are negative?
Okay, so it's got to match, right? So, but I'm saying, like, how can we convince ourselves that must be so from up here? What information, Celia?
The initial condition.
The initial condition, exactly right. When you plug pi over 4 in, tangent of pi over 4 is 1, 1 minus 1, 0, e to the 0 is 1, and we need that to be equal to negative 1. Well, a plus 1 is not going to make that happen. So it's negative e to the tangent x minus 1, which is the same thing as negative 1 plus tangent x. So it is b. Okay? So there it is. Questions on any of that? Yes.
So I had the C on the left side.
Okay.
So I ended up getting just regular 1.
Okay.
And then my equation was still the same thing, but is it okay if I have C as 1 if you put it on the opposite side?
Yeah, because
Okay.
of course, right, because that's how that's what would work out, right? It should be the opposite if it's then just moved to the other side. So
Okay.
yes. Yeah, so different. If you solve for C for different locations of where C is, it's going to alter the value, but it'll still be equivalent, mathematically, value-wise, kind of thing, to what we've got up here. Just if you moved it over and stuff like that. So Lily, do you have a question too? That was that same question, yeah. Yep. Okay. Very good. Moving on. All right. Question 7. Consider the differential equation dy dx equals y squared times 2x plus 2. Let y equal to f of x be the particular solution to the differential equation with initial condition f of 1 equals negative 1. Okay? So, y equal f of x, that's saying y equals stuff with x. Okay? So don't get confused by what this is saying. It's saying, kind of like thinking, a way to think about this is this is y in terms of x, okay? Y in terms of x, okay? So if you're asked to find, for example, the particular solution, y equals f of x, okay, of a differential equation, this is saying solve for y in terms of x, okay? Solve for y in terms of x when you see that. Okay, kind of thing. So just don't get confused by that. Like here in letter C where it says find y equal to f of x. In other words, solve for y in terms of x here. Okay, the particular solution, but make sure you also solve for y in terms of x after that. All right, let's just go through this here. This is a very typical kind of free response style question you might see on an actual test. Okay, letter A. Use the equation of the tangent line to the graph of f of x at x equals 1 to approximate f of 2. Okay, whew, this is like months back, right? How do we find the equation of a tangent line? What do we need? The derivative. We've got it. And the derivative helps us find the what of the tangent line? Slope. And we also need a point. Do we have a point? Oh my goodness, there it is. F of 1 equals negative 1. So we've got our point. Okay. We're told that. And then we also want to find the derivative. Okay, so dy dx evaluated, excuse me, at 1. So since our derivative has both y's and x's in it, we're going to evaluate at the point 1, negative 1. Okay, so that's how we can show that evaluation there. Dy dx evaluated at 1, negative 1, that's going to equal, okay, negative 1 squared times 2 times 1 plus 2. Okay, so 4. Is our slope. All right, and so the equation of our tangent line then is y minus a negative 1, so y plus 1 equals 4 times x minus 1. Point slope form, right? It's been a while since we've seen those equations of tangent lines, but there it is. Okay, so there's the equation of our tangent line. Are we done? No. What are we supposed to do now? How do we approximate f of 2 using our tangent line equation here? What can we do? We're trying to approximate f of 2. Remember that remember the tangent line, we can use it as an approximation of our original function, right? We can use it as an approximation because the tangent line behaves, very close to the original function at that point of tangency. 2 is pretty close to our tangent point of 1. But how can we use this tangent line now to approximate or estimate f of 2? What should we do with that 2? Plug it in. Where? In for x. Yeah, it's an x value, right? So we're just going to plug it in here. So y plus 1 equals 4 times 2 minus 1. Okay. Typically, 2, you don't normally get a 2 there. More, likely they'll ask you to approximate f of 1.1 or something like that, or f of 0.9, something that's closer to the actual, x value of 1 than 2. I mean, I guess it's still pretty close, but something normally a little bit closer. Anywho. So let's see, 2 minus 1 is 1 times 4 is 4, and so we get y equals 3. Approximately is our, that's our approximation. Okay. So, letter B. Find d squared y over dx squared. That means find the what? The second derivative, which is the what of this? The derivative of this, right? So we're going to find the derivative of this to get that second derivative and use that to determine if f of x is concave up or down at x equals 1. Justify our answer. Okay, so we're going to take the derivative of this thing. So d squared y over dx squared is going to equal. How do we take the derivative of this? What are we going to use? Implicit differentiation and the what rule? Product rule, that's right. Okay, so we'll do the second here times the derivative of the first. The derivative of y squared is going to be what? 2y dy dx. Very good. Yes, okay. We're taking the derivative here with respect to x. The derivative of y squared with respect to x. You got to use the chain rule. 2y times the derivative of what's inside with respect to x. The derivative of y with respect to x is dy dx. Okay, it's the chain rule there. Plus, and now y squared times, well, that's easy, just 2. Okay. Oh, I'm off the screen. Yeah, right. Okay, so at this point we have a couple options, right? So what this question doesn't say, that it sometimes will say, sometimes it will say find d squared y dx squared in terms of y and x, okay? So if we had that extra stipulation here of solving for the second derivative in terms of y and x, would we be done here? No. What would we need to still do? Plug in for the dy dx that we've got right there, right? So then it would all be in terms of y and x, right? dy dx is not in terms of y and x. You would have to, change this with, substitute that in here, okay? It doesn't say that here, though. It just says find the second derivative. So we have some options, okay? You can do what we just said, plug this in for the dy dx, and then, plug in your values and stuff like that. However, we could evaluate dy dx at 1, negative 1, which we just did. What is the first derivative evaluated at 1, negative 1? 4. So instead of substituting in this whole mess of the first derivative, we can actually substitute in just the value of 4. Because what are we interested in? We want to evaluate d squared y dx squared at the point 1, negative 1 again, right? At x equals 1, which is also then the y coordinate negative 1. And so we don't need to substitute in the mess of the actual derivative. We can just substitute in its value at that 1, negative 1. So I'm just going to plug in a 4 there. Is it wrong to substitute in dy dx and then plug in the 1, negative 1? No, it's not. But we already found earlier that 4. And this is like a common thread that you'll see when you start, doing these free response questions in AP. Well, free response questions because of the parts. Oftentimes, they try to work in previous work from a problem into future problems. Not always, but sometimes you can use previous work, like that 4 there, to then help you out in the next one too. We don't need to do another calculation, right, to save time, be more efficient. So anyway, we get 4 there times -8, and then plus 2. So it'll be what, 30? Oh, nope. Yeah, 30. Okay. And so is our answer 30 then? No, what does it say? What does this tell us then? F is what? Okay, so F prime prime is positive, so therefore F will be concave up. Okay. Oh, -30. I'm sorry. Thank you. Sorry. Concave down at 1, -1, because, yes, thank you guys. Because d squared y over dx squared is less than 0. Okay, or you could say, f prime prime is less than 0. Okay, something like that at this point. All right, so there's that. Okay, so that is our answer there. Math, arithmetic. All right, letter C. Find y equals f of x. So, like I said, this means solve for y in terms of x. Okay, that's what that means. Given the particular solution to the differential equation with f of 1 equals -1, then find f of 2. Right? Just earlier in letter A, we were asked to approximate f of 2. We got 3, so hopefully when we actually get our function and actually evaluate f of 2, hopefully it's close to that, right? Hopefully it'll be close to 3, hopefully. So let's see here. All right, so dy over dx equals y squared times 2x plus 2. Okay. We're not quite ready to integrate yet to get the original function. We need to separate our variables, right? Dx goes over, the y squared goes over, so we're going to have 1 over y squared dy equals 2x plus 2 dx. Okay, which I'm going to rewrite that as y to the -2 dy equals 2x plus 2 dx, and we'll integrate now. Okay. Integral of y to the -2 is y to the -1 over -1. Integral of 2x will be x squared. Integral of 2 will be 2x, and then plus c. Okay. So with -1 over y equals x squared plus 2x plus c. Okay. And so again, it's your choice. We can solve for c at this point. We can solve for y at this point. So what do you want to do? Solve for c. Okay, c first. Okay, so 1 goes in for what variable? X. And -1 will go in for y. So -1 over -1. Okay, like that. And so we get, I'm going to run out of space here. 1 equals, let's see, 1 plus 2 is 3. So c is -2. Okay, so up to here now, we can say -1 over y equals x squared plus 2x minus 2. Okay. Again, we want to find y equal to f of x. So now we need to solve for y. So I'll multiply both sides by y here. So we get y times the quantity x squared plus 2x minus 2. And then I'm going to get the y by itself, so I'm going to divide it over. So we get y equals -1 over x squared plus 2x minus 2. Okay. And then we're supposed to find f of 2. So 4 plus 4 is 8, minus 2 is 6, so we get -1/6. Okay, not very close to our original estimate of 3. All right, but again, tangent line is not going to be perfect, but it's a better approximation than nothing. Okay, better than nothing. Okay. Questions on any of that? Easy peasy. Lemon squeezy. All right, so for your homework, all right, what I've got for you are 2 things. There's a book assignment, okay, that I think is 3 problems. Okay, we've gone from, well, what, 1, 3, 5, 7, 9, 11, 6 problems down to now 3. Okay, but in addition, I've got a free response question here that I'd like you to work on as well. This is an actual free response question from, not that long ago. I want to say maybe like less than 10 years ago, but I think about 5 maybe. I forget exactly. But anyway, it's a free response question for you to peruse, okay, and consider. I think you should have all the skills for this. So this free response question and the 3 problems out of the book, that will be your homework for tonight. Okay. So let's get started on one of those 2 things. Of course, there's also the problem set if you want to work on that. Tomorrow will be a problem set work day. Okay, we won't be learning anything new per se.
Yeah. Okay. You're like looking around, and I was zoomed in on your face.
I was like, I'm here.
I zoomed in on your face, and then I was like, shit, and you're like, I was like, hey.
It's all one.